Find a polynomial p of x of degree 3 that has integer coefficients and zeros 2 and 1 plus I. From the conjugate zeros theorem, we know that if 1 plus I is a 0, that means that also its conjugate 1 minus I is a 0. So we can set up our polynomial in factored form, basing the factors off of the zeros. So if 2 is a 0 of the polynomial, that means x minus 2 is a factor. If 1 plus I is a 0, that means x minus 1 plus I is a factor. And if 1 minus I is a 0, that means x minus 1 minus I will be a factor. To simplify these, we need to distribute the subtractions in each of them. So this gives us x minus 2 times x minus 1 minus I times x minus 1 plus I, because when we're subtracting a negative, that turns into a positive. Now, there's two ways to go through the process of multiplying these out. One of them is using the table method. We can make a 3 by 3 table with the terms of each of these polynomials on the top and on the side and multiply everything out. Or we can use a special product formula. Let's multiply it out first. We get x squared negative x, ix. We get negative x, 1, negative I, and we get negative ix, and positive I, and negative I squared, which becomes positive 1, because I squared is negative 1, and the opposite of that is positive 1. So when we go through these, we can see that we have a bit of cancellation. I and negative I, also negative ix and positive ix. And when we combine the rest of those terms, I'm going to do it over here, we end up with x squared minus 2x plus 2. The other way that we can multiply these out is recognize that they're going to give us a difference of squares, because we've got x minus 1 minus I and x minus 1 plus I. So that's going to give us x minus 1 squared minus I squared. X minus 1 squared gives us the x squared minus 2x plus 1. And then minus I squared is the same as subtracting negative 1 or adding 1. And so we end up getting the same terms, just in a different way. Now, to multiply all of this out, we're going to use the table method again. So we set up a 2 by 3 table, x negative 2, x squared negative 2x and 2, and we multiply x cubed negative 2x squared, 2x, negative 2x squared, positive 4x, negative 4, and when we combine like terms, we get x cubed minus 4x squared plus 6x minus 4. And this is our third degree polynomial with integer coefficients and the zeros we were asked for.